Hello and welcome to the second lecture in 15th chapter of our comprehensive course on AI, ML and DS. Now here we want to talk about this thing: distribution plots, count plot and box plot. So there are three clear parts. First, creating a distribution plot, next creating a count plot, and next creating a box plot. And as usual, we will start with first creating a data frame. Before I create the data frame, what is the use of each of this type of plot? Distribution plot is useful for visualizing the distribution of data. Now this is very important, and this is one place where SEABORN is hugely beneficial compared to matplotlib. In matplotlib, using matplotlib also you can plot the distribution, but it would be very tedious and lengthy code, while with SEABORN it is just a single line of code. Okay, then why this distribution plot is important? Because many of the algorithms, where before you start building model, you have to select algorithm, that whether you will use linear regression or whether you will use maybe SVM or random forest or XGB. At present, don't bother about what these things are, but there are different algorithms using which you will build your statistical model or machine learning model, which will bring the outcome. Now, in this particular type of case, that is in every algorithm, there are certain assumptions. So you can't use blindly any algorithm for any type of data. There are certain assumptions that this algorithm can be used only if this certain data distribution is there in the data set. Now, how to visualize the distribution? That is very important before deciding whether that algorithm can be used or not. Because if its basic assumption is not satisfied, if the algorithm requires Gaussian distribution and you don't have Gaussian distribution in that column or maybe in most of the columns of your data set, then either you have to think about an alternative algorithm which does not require Gaussian distribution, or maybe you have to convert your distribution to as close as possible to Gaussian distribution or a bell curve. Count plot is used for showing the count of observations in each categorical bin. For example, suppose you have divided, you have a data of 10,000 customers and you have divided them into various age groups, like from 15 to 25, or 15 to 20, 20 to 25, 25 to 30, 30 to 35, like that. But you would like to know that how many customers fall in 15 to 20 and how many fall in 20 to 25 and how many fall in 25 to 30, so that you can target your marketing and you can design your advertising for that age group, which have maximum number of customers and which spend a maximum amount on the product which your company is selling, right? So for that, first you have to know that how many customers fall in each age bin. And box plot is ideal for five number summary. 5 number summary is that mean, median, then maybe standard deviation and variance and that kind of various other things. And outliers. We know that box plot are the go-to plots for using these for detecting outliers, right? So as usual, we create a data frame. This is my first column, and I fill it with np.random.choice. We have already used that earlier, but we know what this will do. Then it will select this choice or this choice or this choice and fill this column category. And how many observations will be there? 100. And here there is one other parameter, that is P for probability. And I can specify certain probabilities. I can specify 50%, 0.5 for this, 0.2 for this, and 0.3 for this. Then in that case, 50% of the observations will be of category A, 20% of the observations will be of category B, and 30% of the observations will be of category C, depending upon 0.5, 0.2, and 0.3 if I have specified. But if I don't specify any probabilities, then equal probability will be there. So out of 100, around 33, and 33 observations, making 99 total observations, they will be of each category. Okay, so 100 rows with around equal number of observations for these three categories, that will fill up this category column. And similarly, np.random.normal and location, that will be median value, and scale, that will decide the standard deviation, and size, that is again the number of rows. So we are creating a 100 row data set with columns, category, and the value. Okay, and once this dictionary is created, we just have to supply the dictionary to the pd.dataframe command. Okay, and if you do that and print df.head like this, then you can see that top 5 rows are like this. And if I want to see the entire data frame, mostly I think 100 perhaps would not be included, yes, but at least I can get the idea that there are 100 observations, correct? So that is the thing. Now I want to know the data distribution, right? So because suppose I want to use some algorithm which has a basic assumption that the data is normally distributed. So let us create a distribution plot for the column value. Distribution plots are created only for numeric columns. They are not created for categorical columns. So import SEABORN and import matplotlib. These are our standard steps. And sns.displot. Now this is often mistake done. Dist people students will write. So please remember it is just a dist plot. Okay. Otherwise in SNS library the names are pretty consistent and you don't have to remember anything. If you know that I'm plotting distribution plot, then this plot. If you know that it is I'm plotting scatter plot, then use sns.scatter plot. If you know that I'm plotting the line plot, then sns.line plot. For example, in matplotlib it was not that simple. Say here somewhere line plot was plotted, but it was not plt.line plot. It was plt.plot. Okay, so some inconsistency in the naming was there. SEABORN is advanced than matplotlib, developed afterwards, and therefore it is very consistent in the naming convention. But this and this, that mistake you should avoid. It is dis plot. Okay, and thereafter other steps are common. First you make the plot. With SEABORN there is no need of that figure step, figure and fixed size. Directly start plotting the plot. Okay, then plt.title, plt.xlabel, plt.ylabel, then if applicable, whatever are applicable, then plt.legend if it is applicable, and plt.grid. Okay, these are the various standard steps, and finally we show by plt.show. So SNS is used, but you should note that for using SEABORN, importing SEABORN alone is not enough, but importing matplotlib is also required, because at the very beginning we have said that it is built, or it is based, SEABORN is a library which is based on matplotlib, right? So you have to import SEABORN as SNS and matplotlib also as pyplot. So what will be the difference? Difference will be only in this step. If I am plotting everything only with that means if I delete this and only with matplotlib, then here also it will be plt.hist, because for pyplot the command is hist, but here I am using SEABORN, then only this line changes. Now it is sns.hist plot. I want to see the distribution of what column? Then I want to see the distribution of that. No, I think this is the old previous example. Here I want to see the distribution of this value column. Correct. So in that case, df value and kde is equal to true. This is the other important thing of the SNS library, that you just specify this command, so it will plot the kernel density estimation directly. Okay, so that is very important. And color, you can choose any color, that is fine. So plot the and value. Okay, what is the problem? Df value, I think I have already created, no, data frame, or maybe this was not. And then okay, yes, so then df value, and you can see that the distribution is not 100% perfect bell curve, but fine, I can use the algorithm which rely on the normal nature of the data. I can do a little bit of feature engineering, and I can make this more normal. For example, this looks to be some kind of only one observation and trying to skew the plot that way. So I may remove it, or I may cap it, and I can bring it within the range of the outliers, or some that kind of thing I can do, so that this becomes more closer to the normal distribution. So yes, I can use my algorithms which rely on the normality of the data. Every time you may not get, sometimes you may even get exponential distribution. So for exponential, you might need to convert it into logarithmic, or some skew is very high skew is there, then logarithmic transformation will help you to reduce the skew. And somehow after applying that transformation, you should get this kind of data. Okay, here I am already having that kind of data. That is good. Now this example I have included on the fly while I was just planning to record this lecture, because I wanted to show you the superiority of SEABORN. How many lines of code? This importing the library is a standard, so I will not even consider. And this is also very standard, same things, that title and xlabel and plt.show. How many lines of code is required to plot the histogram along with the kernel density plot? Then you just write a single line of code, sns.dist plot, df value, that is the column whose histogram you want to plot, and kde is equal to true or false. Okay, if I write false here, then I will get only the histogram. Correct. So let us see that kind, right? And if I want to see the data distribution, which is my main aim actually of using the main reason of using SNS, then I can write kd is equal to true. So that option is very important, and just a single line. Now try to do that same thing using matplotlib, then you are in fix. Say up to this is everything is fine. That matplotlib also can plot the histogram, but about this kernel density, let me take this to next cell, and first let us plot only that much. Okay, so then you will see here also we are importing library, this and this. This IPy will not be required, because it is required for only plotting the kernel density. It is not required for plotting histogram. But here, if I plot, then I will get this kind of histogram. Correct. Now I don't have any, though there is this one parameter, density is equal to true. But using that, I get some this kind of output, but I don't see any curve here. And I want first immediately, as soon as I see the graph, I should know whether it is normal or not. So for that, this matplotlib is not useful. Rest of the things are very easy. You know that this alpha decides the transparency, and if I put alpha closer to 1, then it will be very opaque, dark red, and if I put alpha closer to say 0, then it will be very light. So you can see very light. That is fine. But more important was that density is equal to true option is there in matplotlib, but it will not show you the kernel density. It will give some output like that, and then you have to use that output like in a different manner. How? You have to import scipy library from scipy.stex, import Gaussian KDE, and then create one KDE object using your that df value column whose distribution you want to see. That is this right side column, this column, okay, and then plot that using np.linspace, and that minimum of that column, maximum of that column, that will decide the range. So that means this is the minimum of that column, maximum of that column, that will decide the range for me, and how many parts, etc. That maybe 1,000 part or whatever you want to decide. Here you can put any number, but you should put sufficiently large number. And then you are plotting with that KDE object which you have created here by using KDEX. Okay. Now this plots, and you get this kind of graph now, which was obtained here also, same graph. So it is not that matplotlib cannot do things. It can do, but you can see the complication. One is you have to import another library which has the statistical function. So that is what we wrote in the beginning as the advantages of SEABORN. Here we had written one such sentence that SEABORN includes built-in function for common statistical plots, making it easier to generate complex visualization like heat map, Violin plots, pair plots, so and distribution plot, of course. So you can see that you can plot the distribution plot using matplotlib and scipy also, but who will prefer this method? I would definitely not prefer. So I am deleting this. It was just taken as an example. Now second type of plot, that is count plot. Count plot means what? Here I have this categories, category D. So I want to see how many of the total 100 observations in my data frame. Remember, this is head, so it is showing only top 5 observations. So how many of the 100 observations are in this category? How many are in category A? And how many are in category C? I said here that the probability parameter we have not specified. So roughly equal number of observations should be there in all 3 categories. But let us try to find that. Again, we are creating the same data frame. Just for the sake, I don't have to scroll up. I am creating the same data frame here. And now I am plotting sns.count plot. Previous was sns.dis, dis plot. Now here it is this sns.count plot, because I want to plot the count plot. So SNS is very simple and easy to remember syntax. Again, I have to write what is my variable whose categories I want to find. Then I want to find the categories of category column. Okay, so that means this x is equal to category. Data equals df. So from which x, because in same Jupyter notebook, it might be possible that I have taken several examples and the category column may be coming in some other data frame also. So which was named df1, df3 or some other name. So I want to be specific that take the category column, but from which data frame? Then from data frame df, which is just above created. U equals category. That is, if you don't write this U, then earlier the syntax of this count plot or all many plot of SNS, that was different, but now this syntax is there. So the old syntax still works with SNS, but it shows an ugly kind of warning message, and also gives you a warning that in future versions of SNS this will not be supported. So U is what? Same as what your x variable is. Okay, legend equals false. Here you can write true also, but if there is only one, then fine, you can write false. I will show you both examples. And palette is equal to this viridis. Now instead of this palette, you can have other also. And if you want to know the documentation, then I have told you how to see the documentation. Then sns.count plot and put a question mark. Don't write parenthesis, but put a question mark, and you see the whole documentation. And in detail, you can see what are other color palettes. For example, here this is here names, or maybe some code examples would be given. There, I think the values of the color palettes would be mentioned. Okay, so then you can select the color palette from that what color palette you want. Okay, I am choosing this viridis because it is at such very decent color, and it looks sophisticated. And put the count of categories. I am getting this. Okay, category A, category C, and category B. Since this is a simple graph in which category labels are there on x-axis, x is equal to category and u is also equal to category. The u is equal to category will decide whether the color is different for different categories or not. Okay, and legend is equal to false. Instead of that, if I write legend is equal to true, then what will happen is just here one rectangle box will be created and it will show that what color code you are using, like this. It doesn't look good because it overlaps my graph, so I will keep it false. So this visualization libraries are a bit of trial error. You should try various options and see whatever you find more aesthetic, that you go with. Okay, So this is a function to create a count plot which shows the number of occurrences of each category. So total there were 100 rows here, these 100 rows. So out of which category A has 30 rows, category C has somewhere slightly more than 30, maybe 32, and category B has 36. So as I said, when you did not specify the probability, then equal probability is used. So around 33, 33, 33 would make 99, and here a little bit here and there shuffling occurs, but more or less all are equal in count. All categories have same count. Okay. Now create box plot. Box plot is required for those variable summary, 5-point summary, and other it is required for the detection of outliers. Again, this same steps I have written, copied, pasted, because I did not want to scroll up. So here we are again recreating the same data frame. It is the same data frame, but now I am using sns.boxplot. You can see how easy the commands are for SNS. As if you want to plot box plot, then sns.boxplot. If you want to plot this category count plot, then sns.count plot. If you want to plot distribution plot, then sns.displot. If you want to plot, in previous lecture we have done that. If you want to plot I think profit data I was talking about, line plot, sorry, scatter plot, then you just write that I want to plot sns.scatter plot. Okay, so I get this kind of profit versus sales. And if I want to show the same graph by using a continuous line instead of isolated dot, then sns.line plot. In matplotlib it was splt.plot, not line plot, which gave the line plot, right? So a little bit inconsistency, but here if I try it, then a line is also obtained. Not only that, you can see compared to matplotlib, other important thing is here the matplotlib forces the perfect linear nature on the line plot, while here this tries to capture the distribution of data that actual increase is not perfectly linear, somewhat linear but not perfectly linear. So it is a irregular straight line, not a very perfectly straight line, right? Okay, let me make it again scatter plot, but very easy syntax. So we should always prefer SNS library because of its aesthetic appeal and also it's a simple syntax. Okay, then where are we now? Yeah, box plot. So as I said, I want to plot the box plot, then SNS.box plot. Box plot here is X. On X-axis what you want to plot, then you want to plot category, and on Y-axis what you want to plot, then you want to plot values. And that means multiple box plot will be plotted on a single graph. This is, we have seen this in bivariate analysis. That is a box plot of one categorical variable and this one on the right side numerical variable, correct? So many box plot will be there, and I can compare which category has higher median, which category has a lower median, which category has outliers and which category does not have outlier. So yeah, I think I have to execute this. So first category and then this. Yeah. So then you can see that category C is shown here. So that is this category C. First, its box plot is this. SNS automatically adds the separate colors. Matplotlib does not automatically add. Here there is no such thing. But default behavior of Matplotlib is to plot everything in same color. So here it automatically adds the different colors by this hue, of course. If you don't specify that hue, then it will. But hue equals category, so it will understand that you want different colors for different categories. And then median of this category C is less. Median of this category A is is pretty more, around more than 50, and B is even more than A. Okay. Then you can also see that category C has a few outliers like this. So if required, I should treat them. And category B has some outliers like this. Category A does not have any outlier, correct? Also, you can see that the variance of this category C is less. That means its box plot will be spread over lesser distance, correct? And sorry, it's not box plot, but it's a distribution plot. That is a count plot. If I plot for this, sorry, not count plot, distribution plot, this plot, that will be thinner. But for this, it will be a wider distribution. Variance is higher. This has less variance. This has highest variance. This has also almost similar variance as this, slightly less variance. Okay. So the thickness of the box plot, that gives idea about how much spread out your data is from the median value. Okay. And these points give idea about the outliers. So seeing the box plot is not enough. You should be able to interpret immediately that this has lowest median, this has highest median, this has lowest variance, this has highest variance, this has almost the same but slightly intermediate variance. Okay, then this is having outliers on the both upper side also and lower side of median also. This is having outlier only on the lower side of median, and the middle box plot shows no outlier. So category A has no outlier. This is what I have explained here. So that much I have already explained. And in next lecture we will do about these themes and style customization. Thank you.